This is a WebWork problem that I've been getting a lot of questions on, so I thought I would just go over it for everyone, and so also you'd have it as a point of reference if you get stuck on your problem. So this is from section 3.2. It's probably problem number 1 on your solutions or on your homework set. This particular problem is wanting you to find the derivative, but in a little bit different way. We're still using the same equations that we are, but instead of using as h approaches 0, we're using as t approaches x. And what we can do is consider this synonymous with the case of x approaches a. So we're using that, looking at the derivative evaluated at a particular point. The particular point here is x. So it's a little bit confusing, but we'll step through it and see where we can get. So to get started here, our function is f of x is equal to 3 over x minus 7. And they want us to find the derivative, f prime of x, as the limit as t approaches x of, and this is kind of where we need to take a second to rewrite this. Now this is going to be using that f of t minus f of x all over t minus x. Now you might say, well, wait a minute, where in the heck did this formula come from? Well, this formula is similar to this one. F prime of a is equal to the limit as x approaches a of f of x minus f of a all over x minus a. Oops, so this is an a right here. So what ends up happening here is these are identical formulas. Our variables are just changed. So we're working a very familiar problem just with a little bit different variables. And I will have to say that it is pretty picky about how we input these particular values. So let's go ahead and get started with plugging into our function. So again, we don't drop our notation. Limit as t approaches x. Now f of t, that means everywhere there's an x up here we plug in a t. So I'll have 3 over t minus 7 minus 3 over x minus 7, that's just the original function, all over t minus x. So that gets us started. Now this is actually what goes in this first box. So this expression right here is what they would like us to put into this first box. So this first box right here, they would like this expression in that we have right here. You have to be really careful about how you put it in. Make sure you have your parentheses in appropriately and everything else. Now next they would like us to say the expression inside the limit simplifies to a simple fraction with a particular numerator. Well, if we take this limit right now, we would get 0 over 0, which is indeterminate. Indeterminate means to do more work. So let's just go ahead and do that more work right now. We're going to find a common denominator. So in this first factor, I'll multiply top and bottom by x minus 7. And on the second one, I'll multiply top and bottom by t minus 7. And that gives me the common factor of t minus 7, x minus 7, all over t minus x. So you can see from here, this is very similar to the problem that we did in class where we have to find that common denominator. Now, if you didn't follow through with that, what we did is we multiplied top and bottom here by x minus 7. Whatever you do to the bottom, you have to do to the top. Here we multiplied top and bottom by t minus 7. And that's how we came up with this expression over here. Now, working on from here, we end up with the derivative again, f prime of x equals the limit as t approaches x. And the next blank wants us to simplify. So again, we're working on this second blank. They want us to simplify. So we'd have 3x minus 21 minus 3t plus 21 all over, okay. Now this is actually t minus x over 1. And remember, when you divide by a fraction, you multiply by the reciprocal, so this flips, and I end up with a t minus x, t minus 7, x minus 7 in the denominator. So again, simplifying again from here, I have f prime of x equals the limit as t approaches x. The 3x minus 21, the 3x, that doesn't cancel. The minus 21 cancels with the positive 21. So I'm left with 3x minus 3t all over this denominator with the 3 factors. Okay, so this is that numerator that it keeps referring to. So this is the numerator that they want for that second blank. This is the denominator that they want for that third blank. So again, those values go up here. This would be our second, and this one shouldn't even be there. This is our third blank. And so now we want to go through and find our fourth blank. The fourth blank says, what factor can we cancel? So let's go ahead and look at what we could cancel here. If we factor the numerator, I can pull out a 3, and I'm left with x minus t. And if you'll notice that x minus t is just so close to one of those factors in the denominator, but not quite. So what we need to think about is it's really close to t minus x. X minus t and t minus x only differ by a negative value. So this is kind of where we have to be careful, because WebWork is being a little bit picky here. I almost took it toward infinity, but it just goes toward x. So what we want to do is look at this 3 times the quantity x minus t, and then to get these to match, I can factor a negative out of this first one right here, this first factor, and I'd be left with x minus t, and the other two remain the same. Okay, so x minus t is what the common factor is, and so this value of x minus t cancels, and so this is what they're looking for in that fourth blank, is x minus t. So in this fourth blank, we're looking for x minus t. Now it says we can cancel the factor x minus t appearing in the denominator against a similar factor appearing in the numerator, leaving a simpler fraction with what numerator? So this will be our fifth blank. So let's go ahead and look at what we are left with in terms of our numerator. So here we have f prime of x equals the limit as t approaches x, and let's see what we're left with. We're left with a 3 in the numerator, and this is where it's a little bit picky, because technically we could have factored a negative out of the numerator too and had a negative up here, so it's being picky. It only wants this positive value here. So we have the 3 over a negative quantity t minus 7, x minus 7. So this is our fifth blank. It wants what the numerator is. So that right up here is our fifth blank. The denominator will be the sixth blank. And so this is what they want in that sixth blank. And remember, yours is going to be slightly different, but it's the same values that kind of we can follow through with. Now the very last blank, the seventh blank, is actually what our derivative is, so we need to take that limit. So we're left with here of f prime of x is equal to the limit as t approaches x, sorry I keep wanting to write infinity, of 3 over negative t minus 7, x minus 7. Well, this t is going to x, and so we can see now that we take our limit, I'm going to pop this negative up top. I have a negative 3 over x minus 7 times x minus 7, which is x minus 7 quantity squared. And that is my derivative for the seventh blank. So this is the seventh blank. So hopefully this gets you going on that problem. Your problem might be slightly different, but the same thing will hold true all the way through with the algebra and how it will accept your solutions. So I hope this helped.